Okay, here we are back again. We're doing part 2 of our tonicity and osmolarity assessment. In the first part, we graphed our data, and in this second part, I'm going to show you how to calculate the water potential of the potato core if the temperature was at 25 degrees Celsius. So from our graph in point 1, we found that the concentration was 0.3 molar. So I'm going to come over here, and this time I'm going to use my best friend, and I've got 2 equations for water potential. Notice that the problem didn't tell us anything about pressure, and so we can assume this is in an open container and that pressure essentially equals 0. So to find water potential, I really just need to find that solute potential. So I'm going to use this equation down here. As always, when I'm using an equation, I want to write down that equation first thing. So water potential, solute potential is equal to negative, that's really key, a lot of people forget that, the ionization constant times the molar concentration times the pressure constant times temperature, which is in Kelvin. And whenever I do an equation, I always like to write my variables down here on the side to know what I'm working with. Okay, so I don't know this one. That's what I'm solving for. I do know my units should end up being in bars, a unit of pressure. My ionization constant, well, the problem told me that it was dissolved in sucrose solution, and my best friend here tells me that the ionization for sucrose is going to be 1 because it does not ionize or dissociate in water. So this is going to be 1. Recall from our graph, we found out the molar concentration is 0.3 molar. The pressure constant is always the same, 0.0831 liters times bars over moles and Kelvin. And temperature told me it was in 25 degrees Celsius. Temperature always has to be in Kelvin. So we're going to add 273. So my temperature is going to be 298 Kelvin. Okay, now we're set to solve this. Thankfully, I don't have to do any algebra. Everything is where it's supposed to be. I just need to plug into this equation, being very careful not to forget that negative. So I say 1.0 times 0.3. Molar is moles over liters, and I just do that to help me keep track of my units. 0.0831 liters, bar, moles, Kelvin, and temperature is 298 Kelvin. And I love math problems because I can always double check my work by making sure my units cancel. So I see moles are up here, moles are here, they cancel. Liters are down here and up here, they cancel. Kelvin are here and here, they cancel. I'm left with bars. That's what I want. All right, I feel confident that I've set it up. Now I just need to go to my calculator. I'm gonna say negative. I might have to put that in at the end. 1 negative times 0.3 times 0.0831 times 298 gives me something like negative 7.429. I think for my purposes, negative 7.4 or negative 7.3 bar would be great. I'm going to circle that, and that's how you do it.